Okay, this is the semester one review. I'm going to try to do this in three parts. I'm going to try to do chapter one, chapter two, and chapter three. Chapter two is a long chapter, so that might be a little bit longer. But again, remember, you don't have to watch all of these. I would do whatever you can on your own. Check your answers with the answer sheet that's on Google Classroom. Hopefully, if you look at my work, you can figure out what you did wrong. But if you still don't understand, then watch these videos. But again, don't watch the whole thing. Just fast forward to number 10 that you need help on and just watch number 10. If you want to watch the whole thing, by all means, go ahead and do it. Um, but there's no reason you have to watch all of it if you only need help with a couple of them, or even if you only need help with half of it. Okay, so the first thing I'm going to start off with is the formula sheet. This is up on Google Classroom, but it's kind of nice to see what you're going to get on the final exam. This has all the parent functions up here, talks about stretching, compressing, moving things up, down, left, right, reflecting across the x-axis or the y-axis, and it has all the formulas that we've been using. The slope formula, slope-intercept form, point slope form, standard form. Now, I didn't mention this with standard form, but remember, your A has to be positive, and there's no fractions. So that's a big deal for a couple of these. And then again, if you're finding the slope in standard form, you can use the opposite of A over B or negative A over B. I will tell you before we even start, and if I remember, I'll try to point it out. But there are a couple problems that if you just have this or if you just look at this, that pretty much gives you the answers. So I will tell you that the test is long, but I just got done making the test and looking at it, and really a lot of the questions should be pretty easy and should go fairly quickly, provided that you've studied and that you're ready for it. Obviously, if you don't study, then yes, it's going to be a very hard final. And yet, I mean, there's difficult questions. I get that. But I'm hoping if you study for it, a lot of it hopefully goes pretty smoothly and quickly. Okay, so let's get back to this. Let's get rid of that. So chapter one, a lot of the stuff we did was solving for this one. So we're solving each of these for x. So first we have to, whoops, distribute this negative 3. So we get negative 3 minus 18x is equal to 14 minus x. Then we need to combine our like terms. So I'm going to add, let's see, I'm going to add 18x first. There's a couple different ways you can do this one, but that's the way I'm going to do this. So that cancels. You get negative 3 is equal to 14 plus 17x. I'm running out of room, so I'm going to go over here. Then I'm going to subtract the 14 from both sides. Subtract 14, subtract 14. That gives you negative 17 is equal to 17x. Divide both sides by 17. You get negative 1 is equal to x, and that is your answer for that one. This one looks a little bit longer, but again, it's really not much harder. You just have to keep chipping away at it. A lot of these in this first chapter hopefully aren't too bad because we've been doing it a lot. Now, some of them are a little bit more difficult, 4 and 5 with some fractions. Hopefully when I go over those, you'll remember that. But those are ones that we haven't done a bunch, like number 1 and 2. We've done these a bunch this year. So first off, distribute. So negative 4x plus 10x minus 12 is equal to negative 3x minus 39. Then I can combine my like terms. So that is, remember, I'm not adding 4 to both of those. You're just putting them together because they're on the same side of that equal sign. Some people are still making that mistake. Negative 4 plus 10 is positive 6x. We still haven't changed anything on the right-hand side because we haven't done anything over there. Now is when we can start changing things on the right-hand side because now is when we are taking things across that equal sign. Again, several different things you can do at this point. I like to add the 3x. So that gives me 9x minus 12 is equal to negative 39. So if I add 12 to both sides, you have 9x is equal to negative 39 plus 12. Don't do it in your head. Use a calculator just in case. Divide both sides by 9. You get x is equal to negative 3. Now, number 3 is an interesting one. Um, the first thing, let me try to erase some of this just because I'm going to want to make sure I have plenty of room for this one. Okay, so I'm going to try to fit it in here, but we want to get rid of those fractions right away. So the first thing I'm going to do to get rid of those fractions, we have a 10, a 5, and a 4. So I want to multiply by something that the 10, the 5, and the 4 all could multiply to be. So the first thing I thought of is 10, because 5 times 2 and 10 times 1, but 4 doesn't go into 10. 4 times what number is 10? There isn't any. So the next number is, I would think of as 20. So 10 times 2 is 20, that works. 5 times 4 is 20, so that one works. And then 4 times 5 is 20. So all three of those go into 20. So I'm multiplying each one of these by 20. Now originally when I did this, I told you to rewrite your equation with some space. I still would recommend that. On the test, I try to give you a bunch of space. When you get your test, the multiple choice part is 10 pages. Don't freak out. I try to give you a lot of space, and I try to write things big and clear so you don't get confused at anything. So now we have 20 on top and 10 on bottom. So 20 divided by 10 cancels. So we have 2 on top. 20 divided by 10 is 2. 20 divided by 5 is 4. 20 divided by 4 is 5. And 20 times x is just 20 times x. That doesn't cancel anything because there's no denominator. So now we have 2 times x is 2x. 4 times 3, now don't forget it's a minus, so it's minus 4 times 3 is 12. 5 times 1 is 5. Minus 20 times x is just 20x, not 30. Don't know why I put 30 when I said 20, but we're good. So again, we're back to where we've been at all the other problems so far. Again, 4 different ways you can solve this one from here. I'm going to go ahead and add 20x to both sides. So I know that's not the easiest step to get rid of all those fractions like that, but once you're done with that step, it's a normal problem just like we've been doing. So that is 22x minus 12 is equal to 5. Plus 12 on both sides. We have 22x is equal to 5 plus 12 is 17. Now this is an interesting one. We divide by 22, you end up getting x is equal to 17 over 22. So with multiple choice, that maybe is your answer, but they also may be made into a decimal. That ends up being 0.77. And I put that one wrong on the answer key. So 22, I don't know what I put on the answer key to get that. But 17 over 22 is right, and then the decimal 0.77 is what you should be getting for that one. So on the short answer part, I don't care which one you put, as long as you don't put what I put on the answer key. I put 8.5, and that's certainly not the answer. Interesting. But I don't care if you leave it as a fraction or a decimal. All right, so let's look at number 4. Number 4, there's a couple different ways to look at this. You could look at it like we just looked at the last one, where we need to get rid of the fraction, so I need to multiply both sides by 4. Or you can look at it like you did back in Algebra 1, where to solve this, the first thing they're doing is dividing by 4. So to cancel out dividing by 4, we need to multiply by 4. It all is the same exact thing. But remember, the thing that a lot of people made mistakes on with this is when you do that, the 4's cancel. We don't have a 4 over here. We don't have a 4 down here anymore. All we have left is 3x minus 7. A lot of people distribute and put 12x minus 28. Make sure you don't do that. Add 7 to both sides. I get 3x is equal to 36 plus 7 is 43. Divide both sides by 3. So this one again gets you a fraction, 43 over 3, or 43 divided by 3 is 14.33. And I think that's the answer I got on the answer key, but let me check real quick. Yeah, so that one I did right. And number 5, same thing we just did with number 3. We need to get rid of those fractions. So this time we have a 6, a 3, and a 4. So this one, 12, is going to be the perfect one. You could use 24 or 36. You could use those bigger numbers. that all three of those go into, but 12 is the smallest, so it's going to be a little bit easier. So 6 times 2 is 12, 3 times 4 is 12, and 4 times 3. So I'm going to multiply every single one of these by 12. So that gives me the 12 divided by 6 is 2. 12 divided by 3 is 4. 12 divided by 4 is 3. So what we have left is 2 times x. So we have 2x minus, don't forget the minus. I know it's kind of sloppy. And I still would recommend rewriting this. I just don't have a lot of room, so I guess it's your call, but I would definitely do that if I were you. And don't forget, both of these are x's. So from here, again, we just combine those. So 2x minus 4 is negative 2x is equal to 9. If I just both sides by negative 2, x is equal to negative 9 over 2, or negative 4.5, which again seems, let me check the answer key on that one. Oh, so the answer key, I made a mistake, but here I bet you the reason is. I said don't forget the minus, and I bet it's because I covered it. It's a plus. Sorry, so that should be a plus 4, which means, quick fix, that means this is 6x, so divide both sides by 6. 9 over 6 as a fraction is 3 over 2, and 3 over 2 is 1.5. So that should be the answer to that one. These are the literal equations where you have more than one variable. We're still solving for x. So for this one, we're going to start off by getting the 3m on the other side. Now remember, we're not trying to split up the 3 and the m because we're not solving for m. So we're going to keep them together. We're going to take the whole thing to the other side. So we have 2x is equal to 16 plus 3m. You could have also done 3m plus 16 is fine. Then divide everything by 2. You end up getting x is equal to 16 over 2 is 8 plus 3m over 2. Now it's important to realize there are very many other ways to write that, just a couple of them. If you wrote 16 plus 3m, the whole thing over 2, I would give that to you. I don't think multiple choice will look like that. I'll think it'll look more like this one. Your 3m over 2 could be 3 over 2m. That's very possible as well. And I think there's probably a couple other variations. Now, number 7, there's 2 different ways to kind of look at this problem. And the biggest thing that people make mistakes with is, so we're getting the x by itself. So a lot of people start with dividing by 2. And so they have pi hx is equal to v over 2, which is fine. And then the next step, they divide both sides by pi. But the thing is, when they divide over here by pi, they end up with this tower of fractions. And then they end up dividing that by h. That's confusing and doesn't work. So the big thing you have to realize is if you already divided by 2, now if you divide by pi, that pi actually just goes down here with the 2. Because you already divided by the 2, so you're dividing by the pi, you just put it down with the 2, because you already divided by that. So divide by pi, so you get hx is equal to v over 2 pi. Then divide by h, so the h goes in the denominator again. We get x is equal to v over 2 pi h. So that is what I call the long way. The quicker way, if you want to do it this way, just like I said with the 3m on this one, I can treat, since this is all multiplied, I can treat all these like they're one big number. So I can actually divide both sides by 2 pi h, divide by 2 pi h, and do it all in one step. X is equal to v over 2 pi h. They're both the same answer. It doesn't make any difference, whichever one you prefer. This next one, subtract 2x, subtract 2x. They both cancel, so we're left with negative 4 is equal to 11. Negative 4 is not equal to 11. That's false. So this one is no solution. Label following as no solution. All real numbers are one solution. So for this one, distribute out your 5. So we have 5x plus 10 is equal to 5x plus 10. Some of you guys maybe already know the answer from here, but I still encourage you to keep solving because because some of you guys know the answer already, but some of you guys think you know the answer already and you still miss this. So I keep solving. Those cancel. 10 is equal to 10. Since our variables all cancel, we have no variables left. This is where we tell, is it true or false? This is true. 10 is equal to 10. So this is all real numbers. Now remember, before when we were doing systems in chapter 3, we didn't say all real numbers, we said infinitely many solutions. They are different, but I don't care which one you use. This one, if you subtract 3x, if 4 is equal to 2x plus 4, then you subtract 4. If we get 0 is equal to 2x, that's fine. We still have an x in there. So we end up with x is equal to 0. So this one's just one solution. What is that one solution? Just 0. That's fine. And the last one here, subtract 3x. We end up with negative 7 is equal to negative 10. Again, our variables canceled, so that is false, which means no solution. Moving on to some inequalities. Distribute out this 5. We have 5x plus 15 greater than or equal to 2x plus 3. Minus 2x minus 2x. 3x plus 15 is greater than or equal to 3. Minus 15 minus 15. So I get 3x greater than or equal to 3 minus 15 is negative 12. Divide both sides by 3. You get x is greater than or equal to negative 4. We don't have to graph that, so we're good. If you would graph that, the hole would be filled in and it'd be shaded to the right. This one, I know a couple of you guys did it differently where you subtract 10 from all 3 sides. If you do it that way, that's fine. Just make sure you do it to all 3 of those spots. A lot of people miss it because they don't do it on this left-hand side. So if you want to do it that way, you can. Just be careful. The way I always tell students to do it, I know it takes a little bit longer, but split it up into 2 equations. 4x plus 10 and 4x plus 10 is less than 6. And then just go ahead and solve both of these. Minus 10, that's negative 8, is less than 4x. Divide by 4, divide by 4. Negative 2 is less than x, so that's part of my answer. This one, subtract 10. We end up with 4x is less than positive 4. Divide by 4, divide by 4. X is less than 1. So remember, there's 2 ways. If this is a short answer problem, if you just put negative 2 is less than x and x is less than 1, if you have short answer and you put that, I'll definitely give you credit. That's 100% correct. But if it's multiple choice, they're probably going to squish that together and say negative 2 is less than x is less than 1. So again, they just put that together where we have our first part, negative 2 is less than x is right here, and then our second part, x is less than 1 is over here. Solve each absolute value equation. So remember, with absolute values, you need to break it up into 2 equations. So we have 5x plus 15 is equal to positive 35, and 5x plus 15 is equal to negative 35. So from here, just solve both of these. Subtract 15. 5x is equal to 35 minus 15 is 20. Divide both sides by 5. X is equal to 4. X is equal to negative 35 minus 15 is negative 50. Divide both sides by 5. You get x is equal to negative 10. moving on to this next one. This one actually I think is a little bit easier. So we split it up into our two equations. X minus 7 is equal to 4. X minus 7 is equal to negative 4. Add 7. We get x is equal to 11. One answer. Add 7. X is equal to positive 3 is your other answer. Now this one, before you even start, and I almost fell for this, I split it up into two equations, but I noticed this is a negative 6. You can never have an absolute value equal to a negative. The whole thing is the absolute value is always positive. Absolute values will always be equal to a positive. So if they're ever equal to a negative, no solution. I think there's one like that on the finals, so make sure you look at that. Solve and graph the following absolute values and inequalities. So before I start this, remember, and I'm going to have to erase this, but remember we talked about the land of Gore, and that's where you use this, the land of Gore. So what that stands for is the L is less than. So if it's less than, it's an and problem. If it's a greater than, it's an or problem. So before I even start, my absolute value is greater than, so this is an or. My absolute value over here is less than, so this is an and. I apologize, my dishwasher is running and there's nothing much I can do about it. I need those bottles for tomorrow. So, and this is only with absolute value inequalities. So this is only absolute value inequality. Do not think about this when you're doing compound inequalities, when it's an and or an or normally, like the one we did over here, number 13. Don't think about it for those, only when it's an absolute value inequality. If you don't know if you should use it or not, I would say don't use it because there's not very many of these on the final. There will be a couple, but not, I mean, if you use it too much, there's only going to be a couple you actually use this. So if you forget or if you're not sure, you're going to be better off not using it and missing a couple problems than if you accidentally overuse it. Okay, so let's get started with these. So this is an or problem, so we said it was greater than. And we actually will confirm what that actually means. Or we'll confirm that we're right. So 3x is greater than 7. Now here's the other thing you have to remember. 3x minus 2 is less than 7. So you always have to flip, oh sorry, negative 7. You always have to flip your sign with your negative number. So once you do that, solve just like I did before. 3x is greater than 9, divide by 3. X is greater than 3. Over here, add 2. 3x is less than negative 5. Divide by 3, divide by 3. This one we end up with a fraction. I think I remember that from the answer key. And then when you graph this, I'm going to have to erase this because I'm going to use too much room. First off, if you have a fraction, I know it's kind of annoying, but we know that one's negative, so obviously that's smaller than a positive. So that negative 5 over 3 goes on the left. Positive 3 goes on the right. They're both open circles. Now here's when you can check. If you just graph those like normal, the 3 is bigger than x is going to go this way. The x is smaller than negative 5/3 is going to go this way. So we didn't even look at the or if you did it correctly that way. But it's a good double check because a lot of people forget to flip this sign. And if you forget to flip that sign, then this or is going to save you. So it's good to know both of them. So it's an or problem, so they shade away from each other. And moving on to this one. This is less than, so we know this is an and problem. Again, if you don't do that, you should get it right still, but it's a very, very good way to double check your work. So we have 3x plus 2 is less than or equal to 2. 3x plus 2 is greater than or equal to negative 2. You have to flip that sign with your negative number. So we have 3x is less than or equal to 0. X is less than or equal to 0. So that's one answer. Subtract 2. 3x is greater than or equal to negative 4. Divide by 3, divide by 3. Again, we get x is greater than or equal to a fraction. But again, that's okay, because even if you look at your number line, even though it's a negative, or you should say, even though you know your other number is 0, that's still bigger than a negative number. So even if you don't know what negative 4 over 3 is, It's got to be smaller than 0 because it's a negative. These are both filled in because they have the lines that equal 2 lines under them. And again, 0 is shaded to the left. The other one's shaded to the right. But again, we know it's an and problem, so it's got to be in between those. All right. Let's see, does that bring us to chapter 2? Okay, so that brings us to chapter 2, so I'm going to wrap up this part of the video, and I'll start recording chapter 2.